Find similar sentences using spaCy embeddings for smarter search. By the end, you will build a tiny semantic search demo. You will see how to create custom word vectors, turn phrases into embeddings, rank short documents by meaning, and boost recall with simple query rewrites. I'm Professor Pi, teaching search and information retrieval from basics to helpful practice in simple Python. Word embeddings matter because they let you compare meaning, not just exact words. That boosts relevance for queries that use synonyms or paraphrase. The core property we optimize is semantic similarity, measured by cosine similarity, which captures direction in vector space. The trade-off is memory and compute for dense vectors versus cheap exact matches. On small collections, you get instant wins. At larger scale, you will consider approximate nearest neighbors or index sharding for latency. Think of embeddings as arrows in space. Close arrows mean similar meanings. They shine when words share context but not surface form. They struggle when a single vector must represent many senses or when your vocabulary lacks coverage. For a demo, we keep it tiny and explicit so you can see every step. We will build a tiny spaCy pipeline, handcraft three-dimensional vectors for words like pizza and burger, embed short sentences, rank them by similarity, cache document embeddings, and expand queries with synonyms to improve recall. This snippet creates a tiny spaCy embedding space and compares two words. It starts with a blank English pipeline so we can define our own vectors. The dictionary vex holds small three-dimensional embeddings for pizza and burger, and the pipeline method setVector stores those numbers in the vocabulary, so tokens pick them up. The pipeline property similarity computes cosine similarity between token vectors, which reflects how close their meanings are in this space. The output number is rounded to 2 decimals to keep it readable, and a high score confirms pizza and burger sit near each other in the tiny semantic map. Now we will turn a phrase into a single dense vector. This snippet turns a short phrase into a dense document vector and prints it in a compact form. We pass the query text through the pipeline to get a doc object, and the doc property vector gives a numeric embedding for the whole phrase by averaging its token vectors. The code formats each float to 2 decimals so the vector is easy to scan and output. The list docs holds our tiny example sentences that we will later search over. Seeing the printed vector helps you understand the direction this phrase occupies in the embedding space, and how future similarity checks will use that direction to rank documents. Next, we will score and rank documents by meaning against the query. This snippet ranks the toy documents by semantic similarity to the query string. We've added vectors for extra words like tasty and fresh, so the vocabulary represents the language in our texts. The code treats the query as a doc and computes similarity between that doc and each candidate doc to produce a numeric relevance score. Scores are rounded to 2 decimals and collected as pairs of text and score. Sorting picks the best match and uses a deterministic tie-break on the text itself, so results are stable. The printed top tuple shows which sentence the query considers most semantically relevant and how strong that match is. Now we cache parsed documents and return the top 2 results to save time. This snippet caches doc objects and returns the top 2 most similar texts, demonstrating a simple performance trick. The dictionary DV maps each sentence to its pre-computed doc, so the pipeline does not reparse the same text on every query, which speeds scoring. We keep a parameter k that controls how many results to return. Increasing k returns more candidates, but also increases compute and the size of the output list. The code computes similarity scores against the cached docs, sorts them in stable order, and prints the top k pairs with scores formatted to 2 decimals. This pattern is a practical foundation before adding indexes or approximate nearest neighbor libraries. Next, we expand queries using synonyms to catch informal language. This snippet expands queries with a simple synonym map to improve recall before computing similarity. The dictionary SIN maps informal words to the canonical terms our tiny vocabulary understands, and the code rewrites the incoming query to an expanded or normalized form before embedding. We reuse the cache docs and compute similarity using the expanded query text, so the system can match sentences that use different surface words. Sorting returns the single best match and formats its score to 2 decimals. Adding or adjusting synonym pairs can shift which documents are retrieved and how strongly they score, so the choice of mappings is a lightweight tuning knob. Recap: word embeddings let you match meaning, not just exact words. Use spaCy to assign vectors, embed phrases, and rank by cosine similarity. One caveat: small handcrafted vectors teach the idea, but real data needs larger pre-trained vectors, or indexed search for scale. Next step: scale this pipeline by adding an approximate nearest neighbor index and timing comparisons, or tune the number of results K to balance recall versus latency. Try swapping cosine similarity for Euclidean distance as an experiment to see how rankings change. If practical, hands-on IR helps, subscribe and watch the rest of the series for deeper demos and benchmarks.